Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.
Good afternoon. Welcome back to Renewables. Thank you for tuning in to another week. We're really excited to be diving into season 3 here and very excited to bring you this week's episode with Equitable Solar Solutions. I have the co-founders of Equitable Solar Solutions here with us today, Rich Stromberg, CJ Gooderham, and Maria Agazio. Thank you all so much for coming on the show. This is our first 4-way podcast, so the editing team has a little bit of extra work cut out for them this week, but it's really great to have all of you on here and to kind of hear from various perspectives how this amazing organization came to be. So, if you don't mind, tell our listeners and viewers just a little bit about your background and how you came to start this organization.
Equitable Solar Solutions is a 501c3 nonprofit program. We focus on reclaiming discarded but still functioning solar panels and repurposing those used modules, inverters, and mounts for development in low-income communities. So far, we have diverted about 15 tons of waste from the landfill, and we are consistently diverting more and more as manufacturers continue to innovate. We work with groups that are disadvantaged across the nation, and we also work with solar developers. We started in a classroom at Western Colorado University, and we quickly grew outside of the classroom in the real world and are partnering with groups like Habitat for Humanity and other groups throughout the nation to directly impact families in need.
I'll just tack on there that it was 4 years ago this month that we actually met in this classroom, and I had presented the students. There were 3 other students in addition to CJ and Maria, and I presented them with some used solar panels and told them that, hey, these have been on a house a couple of counties over for 18 years. I tested the modules. They still produce well over 80% of the original power output. So why would we ever think of throwing these away? Which is what was going to happen to them if we didn't do anything. And I just challenged the students with coming up with a way to create the greatest value for those in our community with the greatest need. And that was the only prompt, the only constraint. And over the course of the semester, obviously they got an A and developed a really nice program. But when the semester was over and everyone got their grades and Maria and CJ were walking across the stage getting their diploma, we really felt that this is something we wanted to keep going. So it's the nonprofit that it is today.
That's excellent. So, Rich, you were Maria and CJ's teacher. Are you still a teacher?
So my role here, their actual professor was Dr. Kate Clark at Western Colorado University. And so I was helping her out with a couple of the capstone teams. There was another team and then this group, the Equitable Solar Solutions group. So I was their mentor. I have also been a lecturer, adjunct professor at Western Colorado University.
Excellent. And I'm just curious a little more on like how this got started. Why did you have this solar panel that was otherwise going to be discarded, and sort of what was the impetus for pushing this project?
I guess a really quick summary would be that the fall before January 2019, I was in Sweden for several months as a guest researcher with the Research Institutes of Sweden. It's kind of like their Department of Energy. And University of Alaska had actually paid me to go over there, and I was focused on waste to energy systems of taking municipal solid waste and either converting that the combustible waste into electricity and district heating, or bio waste, their food waste and their wastewater streams, and digesting that to make methane to run city buses and things like that. So I was very much in this mindset of, over in Sweden, what we call trash, they consider to be resources. And they pull all these resources out of their waste stream such that only 4% of the total municipal solid waste actually ends up in the landfill. The rest is either converted into energy or recycled. So I came with that mindset, And there's just the next county over, there's a really nice solar installer who's been working for 25 years. And I saw he had a dozen modules in his office when I just dropped by to pay him a visit and chat. And so I thought, hey, this would be a great opportunity for students. Let's see if we can get some traction.
Very cool. That's great background. And we talk a lot about landfill diversion on the podcast. We're actually in the waste energy business. We have a food waste digester out in San Bernardino, California. These digesters, as you well know, have been operational and cutting edge technology, and Germany has a lot of adoption, but all over Europe for a long time now. And so that's a topic that listeners and viewers, if you're interested in learning more about that, go dig through the old podcast. There's plenty about landfill diversion on there. But again, typically we're talking organics, right? And a lot of today's landfill or diversion laws are really focused on keeping that organic waste out of landfills and waste that's valuable as far as, creating renewable energy or capturing valuable nutrients. And so, but this is super interesting. We don't typically talk about landfilling solar panels. I have seen some staggering numbers on the amount of electronics that end up in landfills that probably haven't really reached the end of their useful life. It's kind of amazing now. You can pay $60 a month, and every year you get a brand new iPhone, and who knows where your old one goes, right? But so talk a little bit about specifically with solar panels. And of course, we're in the solar business, so we have a lot of podcasts about solar too. So this really hits home for the Renewables podcast. Talk a little bit more though, just about, first of all, the scale. Solar, the technology's been around for a long time, but as far as commercially viable and a lot of markets relatively new. Talk about the scale of potentially having to landfill all of these panels from 20 to 30-year-old projects that are going to come offline, and frankly, why this is so important.
Absolutely. Yeah. So to put this in perspective, a number that rings through my brain all the time is that 75 million metric tons of solar waste are projected to be landfilled by 2050. This is a study done by the International Energy Agency through their PPS program. Wow. And again, it's 75 million metric tons of solar waste by 2050, which is just a staggering number. And in Colorado alone, which is ESS's home state, it's projected that 2.5 megawatts of solar and inverters are decommissioned yearly, and that rate is going up pretty quickly. So we're dealing with an enormous amount of waste here, and it's staggering to see how much of this is being directly sent to the landfill. And as we continue to see solar manufacturers innovate, which we want them to innovate, it's wonderful. We're also seeing the rate that these panels are being swapped out increase as well. So it's kind of a double-edged sword. This is just really important for us to try to address this solar waste as much as we can upfront, and to take a chunk of that out of the landfill as much as we can. So just staggering numbers there.
Yeah, I'd add too that there's this paradox of PV modules come with a warranty of 20 or 25-year lifetime, and then they will continue to produce beyond that. So your first question is, well, why isn't everyone using these for a full 30 years? And what's driving some of this that we didn't know when we first started is the increased efficiency in the technology and the continued tax incentives, and for commercial and utility scale owners, the ability to have accelerated depreciation is giving people financial incentives to upgrade their systems well before that 30-year lifetime or so that you might expect these to function in a value-added state.
Yeah, I feel a little bit guilty here. We're guilty of exactly what you're talking about. I mean, we're looking at projects now. We consider, when we sell solar projects, we consider them 30 plus year projects. We are seeing some warranties bump up to 30 years now, which is great. But to both your point, Maria and Rich, which I think is a really important one, you get 8 or 10 or 12 years into a project, and what now is a 500 watt module might then have been a 320 watt module, and you can get more tax incentives, more depreciation. And so you're exactly right. There is incentive to go and sort of revamp these systems much sooner than the true end of their useful life, which kind of brings me to my next question. You mentioned, Rich, I think it was 4 years ago, and at the time the panels have been on someone's roof for, I think you said 18 years. Please correct me if I'm wrong. And you were mentioning kind of the efficiency left in those panels. Talk a little bit more about that. How long do these panels really last? And what happens when you get to 40 years or 45 years? Talk a little bit about the true life expectancy of a solar panel.
Okay, I'll talk a little bit, and then I'll turn it over to CJ to talk about kind of at the large-scale developer perspective as well. So it can vary. There's some modules that were made that the technology wasn't as good. The manufacturers were coming up a learning curve, or maybe they were just getting in on the market and cutting costs too much on their process. And so some of those modules might degrade 1.5% or 2% per year on the output from the original data sheet. Whereas you have newer what I call tier one suppliers like SunPower, who has for more than a decade really focused on what is driving the degradation rates on their modules. And now they claim that they have 40-year modules on their warranty. And I believe them based on how we have tested their equipment that is 12 and 15 years old, that's still meeting 95 to a little bit over 100% of the original data sheet. So it can vary. There's also this mindset, though, here in the U.S. that, let's say you have a car or truck and you've owned it for 5-6 years, and there's a newer model that's more efficient or has some other features that you want to get. So you go ahead and you buy that newer module. So I think it's similar in the solar industry, but you're not going to take your old car or truck and just toss it in the landfill, right? No, it's with our culture. We have this mindset that we're going to trade it in, maybe sell it on the used market. Someone else will do some repairs and they'll be using it also. And for some reason in the solar industry, due to, I think, just lack of systems and networks in place, and certainly not much capacity for recycling of modules, that the default right now is just dispose of it in the landfill. And so besides the technology issues, we're trying to address these mindset and social movement kind of concepts of, hey, you wouldn't throw your truck away. Why are you throwing your modules away? Put them to use. CJ, what do you think from the kind of the large scale, utility scale kind of implementation?
Yeah, so my background is in utility scale renewable energy development, mostly solar. I've done a little bit of wind, but it's mostly been utility scale solar development at the utility scale. And so my role, how I've always kind of viewed my career is decarbonizing on the front end, but then also, in the process of learning about that business, realizing that there's a ton of solar that is coming on the grid, and 20, 30, 40 years from now, the decommissioning requirements, those panels coming offline, it's really difficult to know what the future is going to look like 30, 40 years from now. And the beautiful thing about solar is that it doesn't have any moving parts. It can sit there in all conditions outside for 50 years and still have a relatively good efficiency in terms of output. So that's the beautiful thing about solar. It's all the other part of that too is that time frame oftentimes outstrips the commercial life or really the industry. So, utility scale solar has not really been around for that long, relatively speaking, to traditional forms of energy generation. And so I think being in the utility scale space, there's been so much boom and bust in terms of tax credits, policies that the people who are developing these projects historically, and myself included, like the idea of really thinking through what the future is going to look like 30, 40 years from now is impossible. And a lot of it is like, hey, will the industry be around? There was a good chunk of time there where it was like, is solar going to work? And there are tons of risk takers and entrepreneurs that have dedicated their life to making that a reality. And I feel like it's only been recently where people have, in the industry have said, no, this is a financeable asset class that you can invest in. Solar is going to be here, and it is going to be one of the main forms of energy generation. And so part of that is, a mass adoption, but that adoption, could outpace our country's ability to build recycling infrastructure. But more importantly, reduce, reuse, recycle, the triangle that we've all seen. That's very intentional for those that are listening that don't know. Reduce comes first, reuse comes second, and recycling comes third. So how I've always thought about it, coming from Equitable Solar Solutions, is that recycling is really just one step above trash. It's not the holy grail. And so any way that we can reuse modules is going to be the next highest form of their utility above recycling.
And I'll add on to what CJ said that one of my doctoral advisors, his specialty is PV recycling processes. And what he's concluded is that even when we can extract all the value of the raw materials out of PV modules, the greater value is still in the future generation, power generation of these modules, keeping them in service. It is so many more times greater than the $4 or $5 right now per module that we recover in value. Another thing that we actually have an advantage on the reuse side is when people say they want to donate some equipment to us, we'll first evaluate the equipment, and we have the benefit of hindsight to actually measure it, do thorough inspections and electrical measurements, and see how the modules have degraded over time. And we can see what's the good stuff and which manufacturers and model types didn't age so well. And so we can exclude those and just recommend those for recycling and make sure that our customers are only getting the really good stuff.
That's super interesting. I would like to know some of the results of those tests, actually, Rich, as I kind of look forward and plan for new projects, right? Like who's hanging in there the best? Who should we be buying? I want to ask you one question on the $4 to $5 in value. Is that the cost that you could sell that panel to somebody who would reuse it for? Or is that where you're getting that $4 to $5 in value? Is that like the aftermarket like resale price?
That $4 to $5 is the market value of the raw materials, the constituent materials, the aluminum, the glass, the silicon, the silver, those kind of things. Versus on the market right now, there is a small used market that is mainly for people who have a system and maybe a trash can blows in the wind and breaks one of their modules, and they want to replace it of the exact same type. So right now, that's the main reuse market and value there.
And certainly, if you can find a home for that reused panel, it should create more than $4 to $5 in renewable electricity, right? So that's kind of what I was trying to get to, was just to kind of further make your point that reusing is definitely the better way to go as opposed to just scrapping and making $4 or $5. So that's all super interesting. One of the things that you've kind of touched on here is kind of the cultural piece and always wanting the latest and greatest, which is no doubt an American thing. There's a lot of wonderful things about America, and maybe some people think it's a good thing, maybe some people don't, but consumerism is certainly kind of the American way, right? So what I'm curious about is, who are your customers? And, to me, I think of 20 plus year old recycled materials. Like, is there a big enough market for that in the US, or I heard you say at the top of the show nationally. I know this sort of started as a more of a local mission, but how do you sort of view this as you continue to grow and there continue to be more and more materials that are available for reuse? Like, who are the customers? Who are these panels ultimately going to and benefiting? Is it residential? Are they going, eventually as we scale up and up and up, are we talking third world countries? Elaborate on that. Kind of what's the state of that now? And I guess where do you see that going?
There is a huge market for these panels, and we really focus on low income families and groups that are typically 400% below the federal poverty line. That's our target market. We have a sliding scale of groups that we work with based on their need. And we are working to implement those on residential properties, also working to implement in commercial properties, multifamily properties. And then in the future, we are identifying how we can grow this to utility scale arrays that are benefiting large communities. So kind of a variety of clients there, but really just focusing on families who are the most disadvantaged in communities. And then also on the other side too, as far as people we work with, we're assisting some of the largest independent power producers in the nation to divert this waste. We're working with groups that are really on the cutting edge of utility scale development, and we're helping connect their resources with the communities in need on the ground. And so trying to take the large scale business organizations and really tie those in with individual families, and also with developers who are creating low income houses for those groups. So definitely focusing on implementing in America currently. We are trying to keep our resources in America. We don't want to take panels that are secondhand and put them onto other developing countries' shoulders, because they will end up having to deal with those resources at the true end of their life. So we would just be kind of transferring the benefit to them. And so we want to make sure that we are being responsible about where we're placing these resources. And so if we're getting them from America, we want to use them in America, and then at the end of the life, take care of them in America. In some cases, it may be beneficial for us to send them out there if they're really high quality, but that's just not our mission at this time, because again, we don't want to further disadvantage growing communities and other nations that are still developing with our what could be perceived as waste in the future. So again, just currently focusing on using these resources as locally as possible.
And
very interesting.
Hard numbers. Just for Colorado, there are more than 60,000 households in the state of Colorado that are that qualify for federal LIHEAP assistance. LIHEAP being Low Income Home Energy Assistance Program. That's federal dollars allocated to each of the states. And so with 60,000 households, there are so many more people that are energy burdened and could use our assistance than we can presently serve.
That's really interesting to know. So I want to push on that a little further, and then I want to talk about energy burdens. But first, I want to elaborate on what you just said a little bit. So this LIHEAP program, can you tell me a little bit more about that? I'm not particularly familiar. And does that help? Because I'm sure there's still a cost here, right? You have a developer who says, I'm going to decommission this 10 megawatts and I need to find homes for it. It sounds like you help with that. That's really interesting to me that you're working with the developers, and makes sense because once it's in the landfill, it's kind of too late, right? They've thrown it in there. I'm sure not so gently, and I'm assuming at that point it's scrap. But talk about kind of the cost of actually getting these panels to the folks who need them, getting them installed, getting the other sort of balance of system equipment that needs to go with that, and any programs. It sounds like maybe this LIHEAP's one of them that sort of help with the cost of that and getting these panels up and running for those who need them.
The cost can range on a project depending on how much reuse equipment we have in inventory and what might work for a particular house. So we have to kind of look at roof space and their energy load. But we combine both our contributed equipment as well as volunteer labor, and then we partner with a local licensed solar installer who's the project lead of record. They take care of the permitting and submitting the designs, and then we work with them. So it takes fewer crew members to complete the install. But we've done as low of cost of one system for Habitat for Humanity homeowners that we had the rails, we had the modules, we had the inverter, and all
Nice.
we needed. We didn't have the L feet for the rails, but we had everything else. And then we just needed some cabling and DC disconnect, a few other things like that. We built that for 90 cents a watt for these homeowners. So very, very cheap. A lot of what we get on our projects is around the $1.85, $1.90 a watt, because we need to have rails, or maybe the inverter that was on the old system no longer meets the NEC code, so we can't put it on a new house. But
Sure.
Still, we have significant cost savings on those projects.
Fantastic. That's definitely a cut rate price. So very, very impressive and interesting on the volunteer labor piece.
Yeah. The other thing, too, that we make very clear with our installers is we serve the lower income populations that could never afford a brand new system, because we don't want to compete with solar installers on those households that do qualify for tax credits for renewable energy systems and have a higher income and actually lower energy burden. So it's like, hey, that's your core business. Focus on that. We don't want to compete with you. We want to partner with you on these other projects that kind of expand who can get solar that wouldn't be able to afford it otherwise.
Excellent. Are you ever able to keep the warranties intact? So if it's a 25-year warranty, but you're in year 18 and you take it from site A to, house B, are you ever able to keep the warranties intact?
So the warranty, usually there's not an exclusion of moving it to another site or transferring to a different owner. The biggest challenge is all the companies, both those that had manufacturing issues and those that were top tier suppliers that for some reason decided to get out of the business, like a Kyocera or a Siemens. And so they're just not around, and navigating that warranty system could get really difficult. And so the easier path is just to keep some of these modules in inventory to do quick drop-in replacements. It's just, unless we had a system that was very new, it's probably going to be difficult to even find somebody to talk to on a warranty replacement.
Sure. And is that a service you provide? So if you install on a household and a panel goes down, they can call you and you help them get it replaced?
We do. We haven't kept spares on everything, but more and more we're doing that as we kind of read the reality of when you get a big company like a Sharp that made really good modules, and they're also not in the business anymore. It's just prudent, and also talking with some of our international counterparts, it's just prudent to keep some spares and get a quick replacement versus waiting for months. Or in a lot of cases, you're more likely to just get a check from the manufacturer because they don't have any inventory, and then you're calling around trying to find an exact match.
Sure. Interesting. Okay, so you mentioned energy burdens, and I saw and kind of researching you all online, talking about energy burdens and environmental justice. Tell our listeners and viewers, what that means to you from your perspective at Equitable Solar Solutions.
Yeah. So electricity rates are equal, not equitable. So in the same utility region or service territory, one household that has an annual income of $300,000 per year and another household that has an annual income of $35,000 per year are going to pay the same dollar per kilowatt hour for electricity. So in most of the modern world, and here in the United States, almost everybody has access and is heavily reliant on electricity for everyday life. So in simple terms, electricity costs take up a much higher percentage of household annual income for low income status households than moderate to higher income communities. So some studies have shown that for low income households, that might be 10 to 15% of their annual income is allocated to electricity costs. Whereas to moderate to high income households, that percentage on average might be 5% or less. So low income households are often far less energy efficient than homes that are of moderate to high income status. That's another component of the energy burden issue is energy efficiency in terms of the housing. Furthermore, residents that live in low income households oftentimes don't own that property and therefore don't have the decision-making ability to put solar on their home, but more obviously, they don't have the extra money to lease or purchase a residential solar system. So there isn't much of a choice for this specific demographic to choose where their electricity comes from or to have some choice in maybe their cost of electricity that you can get if you're of higher income status through getting a solar residential system on your house. So they're kind of beholden to what the utility rates are and what the utility rate or what the utility is procuring power from. So going back to electricity rates not being equal, or going back to electricity rates being equal, not equitable, there's a very intentional reason why our name is Equitable Solar Solutions and not Equal Solar Solutions. So in terms of environmental justice, the useful life of solar panels far outlives the commercial life of systems that are being installed. And so currently, the best way that the solar industry has found for the end of life for these solar panels is for them to either be recycled or, in some cases, even worse, being thrown away in some cases. So, what this essentially means is that potential opportunity for low-income households to alleviate their energy costs and participate in decarbonization is literally being thrown away or recycled into tiny bits of scrap metal. And that's where Equitable Solar Solutions comes in to extend the life of these panels and redistribute them to those with the greatest need for them.
And so another portion of those low-income households that's the greater need than we've been able to currently help are renters. There's 65% of low-income households don't own the place that they live. So how can we help renters, and how can we help them in a way that their landlord doesn't know they're saving $75 a month on their utility bill and just raise their rent by $75 a month? And so our kind of 3 to 4 year plan out is to build our first commercial or utility scale, kind of small utility scale community solar garden that is within a utility service area in a large field or on a large building rooftop, and then split up the energy generation of that array across many rental ratepayer meters at the utility. They kind of do the net billing, and that way they get assistance even though they don't live in a place where they can put a solar array, either because they don't own it, or there's shade, or it's multifamily housing that's not enough roof space, those kind of things.
Yeah, super interesting. I'm sure we certainly follow the community solar programs across the country and working on a couple projects in community solar. So I think that's a fantastic way to increase adoption. I hope we continue to see more and more states and utilities roll out programs like that. And I'm sure from your all's perspective, there's less pushback, right? Or no, there really can't be pushback from the landlord, because I can't imagine being a landlord, you might push back and say, well, this tenant might want it, but what if the next tenant doesn't, or the system breaks? Who's going to fix it? And so I'm sure those are issues that you're having to work through that community solar kind of squashes.
Now, there are some places I've seen where there are local governments that own and operate the income qualified housing, like Taos County in northern New Mexico. They own a lot of these multifamily housing facilities, and we would work with them because their mission isn't to make a profit. It's to provide the most benefit to the people in their community with that need. So we would still work with them and do on-site type of solar arrays, so long as we could figure out how do we split it up between the meters, and different places are metered differently. But so there are ways to work with landlords, but we can't do it in all situations.
Sure, that makes sense. So, Rich, you in founding ESS decided to pursue a later in life PhD. Talk a little bit about that and why you felt that was necessary.
Yeah, I have to say Ron Burgundy is my one of my heroes when he says that escalated quickly. So we started working on this, and we had a certain mindset when we were doing the semester project, and then we started putting it into action as part of the nonprofit under Cold Harbor Institute that's been our parent 501c3. And we realized, hey, this is a lot more than just the technology. There are social and cultural factors we need to understand on the clients that we're trying to serve. What has been their past history of social and environmental injustice in their communities? Have they had industrial and environmental wastes dumped within their communities? And are they going to see used solar equipment as just another example of that, or do they see value in this? There's also just kind of outreach and awareness and education of how solar arrays work and might benefit our clients that are a higher need and energy burdened. So then there's also policy issues at state, federal, local levels, policies with one utility versus another. If you're operating with TVA in the Appalachian states, that's so much more different than working in Colorado or working at Salt River Project in Arizona. And then there's the ecology issues of landfill diversion and what the life cycle analysis numbers do if we can extend the real life of solar out to 40 years. And then obviously the technical issues of what's the quality, reliability of issues across the broad range of suppliers. And then lastly, it's how do we build a sustainable business model besides the social movement? How do we have this business model where we don't rely on grant funding forever, that we can become self-sustaining? So University of Alaska Fairbanks has a College of Interdisciplinary Studies, and they had approached me about a year and a half into this whole equitable solar solutions thing and said, hey, Rich, we're putting together a non-traditional cohort of PhD students. Are you interested? And I said, yeah, but this is what I want to do. I want to work on reuse of solar PV systems for social and ecological benefit. And I'm kind of swimming up the stream. Normally, you have a professor, a PhD, who already has in mind a scope of what they want you to work on. And instead, I had to propose the whole scope, pull my team together. I've got a great team of advisors. But yeah, this is not for the faint of heart. I'm not doing this for letters behind my name. It's to show a personal commitment to the program, to everyone in the industry, that I believe in this, and that helping them to understand all the different factors we need to address in order to make reuse a long-term viable model.
Excellent. Well, very, very impressed with the good work that you all are doing. I'm really excited to continue following along your journey here And we might have to bring you back next season and kind of hear how things are going and check in. We like to do that. This has been so informative. It definitely hits home, I think, with what our listeners and viewers are looking for. Ultimately, solar is a big piece of the renewables transition, and getting sort of access to everybody, I think, is so important, and making sure that not just the big corporations of the world who have set, impressive ESG goals, but really making clean energy accessible to everybody. That's exactly what you all are doing. And I am so grateful for you to come on the podcast. We've had a great discussion here, a little bit longer than our average episode, which I think is great. I've loved learning more about your company. So I will be following along. Tell our listeners and viewers how they can follow along with Equitable Solar Solutions. How can they find you online? Or even better, if this episode has piqued someone's interest and they want to connect further and have a discussion, tell them how to do so, and then we'll wrap it up.
Yes, I would say the best place to stay up to date with us on our projects and upcoming volunteer opportunities would be our LinkedIn page. You can find us at Equitable Solar Solutions. You can also check out our website at Equitable Solar Solutions with an S at the end of solutions.com. And you can donate equipment and or funds there at the top of the page. There's a little button you can push to input your information. You can also reach out to our info email and send us a note if you're interested in volunteering. So a lot of things to stay updated with us on, either on our website or on LinkedIn. And we'd love to hear from you, either directly on LinkedIn or via email.
Perfect. We will make sure those links are in the show notes. Really, thank you again. This has been such a great episode of Renewables. Rich, Maria, CJ, it's been great to get to know you through this process, and really look forward to keeping up with the good work you're doing. To our listeners and viewers, thank you as always for tuning in to the show. We're continuing to see amazing growth with the podcast. Never could have imagined just a couple of years ago and starting this that it would have grown to where it is today, and that's because of you. So we really appreciate you checking in, listening to the episodes. Hit that follow button wherever you listen to your podcasts. This has been another episode of Renewables. I'm your host, David Smart, and we'll be back for a lot of great more episodes coming in season 3. Stay tuned in, and thank you for listening.
Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.